It gives me great pleasure to introduce our next speaker, architect Bimal Kachroo, Director, Holistics Urban Innovations Private Limited, Noida, an innovative architectural project management company that offers high-end sustainable, bioclimatic, bionic architecture, engineering, and master planning services.
Good evening to the Fraternity of Architects and Planners. I'm Bimal Kachroo this side. I did my master's from SPA in 91 in urban planning. I've been running a practice of green architecture for 25 years in Noida. My head office is in Noida. And I've contributed a lot of SNUs of economic power to the skyline of Delhi, Bangalore, and all pan-India. I had always a penchant for green architecture, and it has been a passion for the last 25 years. Regarding SRM, it's a pleasure to associate with SRM program, especially this iconic BEST 2021. It's a great opportunity for me to be a part of this conference, especially when you interact with international speakers, you get to know the international frontiers of technology, the latest that happens in green building concepts, and interaction always makes you better. I think this is a great opportunity for me. Thank you. My topic is eco-design for sustainable build forms. See, it's a paradox always in the Indian architects. We want to be modern and return to sources. And how to revive this old dormant wisdom in a civilization and to take part in universal civilization is the frontiers and the issues that the Indian architects are facing day in and day out. My philosophy of design has always been, Wordsworth is a great inspiration, the piece of vernal wood will teach you more of love, of moral evil and good than all the sages can. Though it's a very simple statement, but carries volumes and volumes of design philosophy in it. See, ecological design is nothing, it's basically air, water, and land, climate, soils, whatever affects the built form. Directly, there are about 3,200 systems. I have not been able to put all these systems here, we'll make a jargon of technical this. So there are 32 systems which work on one built form. Maybe a group housing, maybe an IT park, maybe in a college. The ecology design should take into account all these systems and adequately duplicate the complexity of natural ecological systems. It should know the Mother Earth as the supplier of energy and material resources. The whole system should know how to recycle, reuse, and revisit all the wastes that exceed the capacity of the environment in these days, especially plastic and electronic waste. The designers should have expertise to be critically expanded in terms of wisdom, to include sensitivity, economic analysis, operations during useful life and life cycle costs. See, the theoretical framework for ecology design is very simple. You have every system. When you come next to the presentation, you'll find out how HUIPL has designed building systems. So generally a system has output and input. There's a process in which there's a benefactor, there's a beneficiary, there's an obtruder, there's an objective in the process. Now with all these things, if you see econometrics of ecology, sustainability and design, they should give ecologically sustainable design, which is itself a sustainable concept. So you come from part to whole, you come from whole to part. It's better to come from whole to part in this case. So the systems of operation should sustain the building in life cycle cost for 80 years. It should be systematic, comprehensive, and environmental impact assessment should be minimum. It should remind that the scope of anticipated non-impacts of environment that on a human body, like we have wellness index now, we have the indices coming out, and have one look interaction for emphasis on importance of single factor that is producing no lapses in design. See, I personally believe with my 25 years, 30 years of experience in design, it's very simple. The design emanates from 5 elements of life only. That's earth, fluid, spirit, air, and fire. If all architects know, whether it's biomass, built form, or ecology, these are somehow related in some alpha, beta, or gamma way with the whole process. See, whenever we design buildings at HUI, we have these objectives that we want to create a state of, generally all architects have this. They want to create a state of art, futuristic buildings. They want to benchmark it with the best in India. They want to aim for LEED Platinum, passive solar techniques, rotation, this thing, green vertical walls. This is where it starts. The green thinking starts. But this is where our design ends. How we have gone, basically every design process has an activity pattern and a circulation pattern. It has an activity concentration and a circulation concentration. How to delineate it properly is where the designer, and how to make it interact with the environment. This is what's most important for any eco-design building. See, the general building goals in India right now, you see, everybody wants to have office complexes with USGBC, TERIGRA, and B. This is all component level, the building level. But what impact it has on the biomass, the grey water system, the blue water systems, what is the effect on the total environment, and then as a component of the whole world, it needs to be seen by all architects before design them. See, I had been emphasizing in all the seminars that whenever we epitome something as best modern architecture, it is not modern architecture. We have modable grids, 8.5 for offices, 4.5 for residences. These all things are okay when it comes to the box thinking of form and function. If you actually want to see from biomimicry to bioclimatic architecture, you should see the building as a part of a larger process of biomass, as a larger process of blue systems, a larger process component of air, water, and even the temperatures that we have regarding what we call it the mitigation of the heat island effect. See, there are two phases, the building design and the master planning part of it. So if you see the eco master planning process, it has simply 4 systems. The blue infrastructure, which contains water supply, water bodies, water life, aquatic life. Then you have grey infrastructure, which is water, roads, sewer lines, water circulation, grey water, and this how to do watershed management. Then you have red infrastructure, which is human body, human life, human population inside a building, their interaction with the environment, how you have to make the walkways, their relation with built forms and the perception of the built forms. Then you have green infrastructure, which is generally landscape, green linkages, linky greens, and then a lot of ecospace. See, in the eco infrastructure, we have listed certain factors which are the objectives of a design. That whenever we do a green infrastructure planning, we should classically see and conserve natural features. Ecological connections to the whole process should be in terms of air, water, land. It should not be physical. It has to be conceptual also. Then retention of biosphere. Whatever component of biosphere is there with us in that small area we design, we contribute to that. Then prevention of air and water pollution at that component level only. And then microclimate control, which is very important in terms of mitigating the heat island effect. Then blue infrastructure, we have water conservation, where we have water harvesting, which is very old now, water conservation, water balance tires, zero discharge systems, then proper disposal of effluents, the technologies we change for SLET for STPs, then accessibility of clean water and existing land use patterns, very important. Most of the projects which we do are based on authority where water is to be carried from Ganges to Noida. So we should try to see that how the whole process can be taken with less water usage, innovative water technologies, how we can put less stress on water, especially at the sea level and at the national level. Then grains start with large engineering systems such as roads, sewers, drains, eco-engineering, efficient transportation systems, battery-based, then energy utilization for this transport, how to reach the site. Now, most of the people generally say that we can use bicycles, is not possible. So you have to have eco-gadgetry hardware and you have to have efficient transport systems. Recently, Toshiba and these people have developed in Japan 100% green power battery transport system for railways. So such type of inducement of like Tesla cars, like the cars of the future, small passenger cars, then work place relationship with your office. These are some of the things you have to consider while because you are drawing on a line on a drawing board, which has a cost at site, which has cost to environment, cost to thinking, and overall cost to human life, overall cost to national infrastructure, overall cost to national imageability. Then red infrastructure, as I discussed with you, concerns people, spaces, proper activity should be there, proper circulation should be there, interface between perceptual and intellectual spaces. Like when you design more than 10 acres of IT park, we keep a lot of areas in the plaza design. We keep brooding forests in our design. So in most of the projects we do, we have a small brooding places. We have some fountains distributed where people can have leisure time, read a book, or have some pensive moments. See, the design is objectives of planning. What we is the basically from the economics, you have a social grid, you have to have an energy efficient grid, you have to waste recycle grid, and this should give to one synergistic water. Now, how to go up in a building? What should be the land use matrix on econometric model, energy model development? How you can make it a lot of models on it, adoption of green development norms, both USGBC, IGBC, SOCM, whatever you want to take. Perfect blend of ecology and environment. See why generally people say ecology is a part of environment. We say it is not. Environment is based on other factors. It's based on land, water. Ecology is larger. It's on biomass, aquatic life, the natural runoffs. So we have to integrate both of them. Then you should have landscape, which can include major theme parks, and sport complexes together. Then it should be equipped with state of our physical, socio-economic infrastructure, like net infrastructure, net connectivity, charging points, battery charging points. This is a part of the planning process now. Like 10 to 15 years back or 2 decades back, we used to see glass as a medium of showing a slew of economic power. Now these things are slews of economic power. And always people started talking about watt per square feet in office spaces. People started talking about generic power. People started talking about wastage of power, light watts. This was not initially there. People started coming to talk to a fossil fuel level power also, cost per square feet of fossil fuels to run a complex. And then fifth generation intelligent regions we should have with full use of information communication technology. We should use technology to enhance the green mass, enhance the ecological parameters, and enhance the green parameters of development. See, this is the methodology we use generally in planning at our office at HUIPL, which we have designed over time because of our experiences. So what we do is we have a lot of 24-hour supply grid. We have connectivity systems. We understand all these factors like sustainable sites, water as per USGBC, then recycle and reuse, sustainable low energy development should be there. Then other issues of bylaws, social, has to be augmented with roads and services. And then you come with fairness development scenarios, which are both efficient, spatial wise, behavioral and perceptual wise. And then we come to sub-regional economics. What was the plot size? We did a township in Dehradun 10 years back, which was zero discharge at that time. Though it was on the bank of a river, we didn't drop of water from the river. We had municipal supply and our own augmentation systems. We were first to use watershed management, rainwater cultivation tanks there, which was distributed again by gravity to the people. Now, what in India, what we miss mostly in our country is that we don't have an evaluation of or review of our built-up programs. That whenever we make a we never have a survey that if a city had biomass of more than 20 acres, city had other requirements of greenery, which are already present, and how to save the ecological footprint. So that is where the whole thing comes. What we try, our modest effort is to save this ecological footprint and have least environmental impact on living conditions. Then in preparing the design brief, the designer has to find out basically shelter and comfort at what energy cost it is there. Now, if you see the contemporary architecture now I'm coming to the component level building design. See, if you see contemporary architecture there, after we do the planning part of it, we have green architecture also in place. We have high-tech architecture also in place. We have creative architecture. We have parts of Bionic architecture in place. Now, these all styles, Bionic is one thing we are now going into, because all these natural shapes which are coming all over the world are based on the thought that some of our biology and plant structure is structurally safe. It is environmentally friendly. It has all the process of carbon cycles, carbon rating points, and oxygen production systems. So that forms the basis of fractal geometry. It has from top to bottom, has to be used in building design for structural efficiency, for water use, for how to take things from back atmosphere and give back into atmosphere in terms of water, how to make green covers and increase the green life, green cover for the whole concept. Now, what the hierarchy of ecosystems, we have mature, immature, amplified ecosystems. See, when we see that 75% of the world's energy resources are forest pollution and climate changing gases are due to buildings, activities and services and transportation. We should know the role we play. What is the total quantum of pollution we create by doing these buildings? And skyscrapers have never been anti-friendly. It's a misnomer in people. They are electric guzzlers. They are a strain of infrastructure. They are a strain on power. If you design a proper, it's a steel. It's a vertical steel. What Franklin said, a 1 mile steel. It's a vertical steel which you can develop the same parameters of normal horizontal steel and better than that in terms of green cover, in terms of oxygen production back to the environment, in terms of waste usage. You have more collector basin per square feet, 1,000 times than normal landform of 5 acres. If you take the FAR of 3 and 5 acres, then natural immature systems, we have to think very clearly that we have to allow them to grow and regenerate. Then amplified economic systems, we have to see that what is controlled burning, why we mow or selectively logged areas by biotic components. We have to be very sensitive to the steel level biotics. Now, methodology for preparation of a plan. Basically, this is a presentation. I will go fast because most of zones of information and sub-regions, it's like master level, plan level. It's basically what should be the SWOT, what are the materials to be used. So I'm going fast on this because it's basically an additional legal how to go, especially for planners who are responsible for large-scale ecological disasters. There's another problem, how we define the monitoring, evaluation, and EF application design. That is the hydrological regime, main objectives, how we enforce. This is the jargon. Whatever goes in environment investment, water pollution, land pollution, air pollution, you connect these, all connections have to be made by the designer before he designs a building of a scale of more than 2 acres, with a FAR of 2.5, because then he is contributing to everything. Now, second part is very important, the management of energy and materials. Now, everybody says that we have to be water positive, we have to be air positive, we have to be recycle positive, all positives are said. But when you actually come to building design, the issue starts. If you have augmented power of 5 generators, it takes all the carbon credits off from your design. So that is why the challenge for designers come. The waste, recycle of waste is the most important thing that people should consider in embodied energies, that is biomass, how to retain energy from these parameters and sectors and put them back after channelizing them properly into the building. Then material selection education has to be as per UL listed, NFPA guidelines, and that's part of design. But like reinforced concrete, it is recycled, but it's never recycled. You never get steel in the same form. There's a lot of carbonation that takes place. There is a lot of acid action. There is a lot of things that happen to carbon steel once put in casting. So these things are all theoretically done. They don't actually give any result. So while designing a concrete frame structure, you should see the embodied energy. Whatever energy has gone to steel for making that kind, does the recycled content and claddings that will go into it give you the same amount of reuse, at least 50% of the reuse what you are putting into. And now you know the fossil fuels, next 15 years, how the world is going to behave. It has to be power based on green fuels and solar, bioclimatic, biogases. So this is the thinking, and wind, which is, I think, the major source that will be in future because solar has issues. Now, what we want to highlight now is that how we have designed the building design into subsystems. We have a building structure system, which has directly an impact on eco-engineering, the infrastructure, and it can control the pollution activity while construction. Then the building transport system, that is the lifts, escalators, parking, travelators, corridor concept. Here is where you have to optimize energy performance in fundamental commissioning and verifications. So you should know while selecting the lift systems, travelators, and how much energy is going to be used per power per cycle. So everything has to be quantified per cycle, per square feet, power consumption into parameters. Then you have building power lighting systems. Then lighting is a very important factor. If you have proper daylights in building, daylight design, so this system can be taken care of. Then you have building air quality system, where ozoners, you basically have to see that whether how much you can trade off without areas being cooled by convective convection rather than by doing it with HVAC systems. So the design of air conditioning system has to be environment friendly. It has to be as per Montreal Protocol. It has to have carbon sinks in consideration. It should be designed that way. And then you should have innovative technologies like we are doing this land pooling systems, piping systems in one of our projects in 73 in Noida. So those types of innovative technologies, vertical drafts, then floor-based ducting systems at vertical levels only, not because India, we can't afford to have 3 floors. So you can have a central shaft and there are systems of doing it. Then you have this building blue engineering. This is most important, where water supply matrix is there. Because water is another source. They say the third world war will be water. So it has ingredients like water diagram, balance diagram, water treatment plant, water systems, and then water transmission for the plants. So this is where the best public health engineers that they brought in for any skyscraper or any building design, so that they have a net zero water balance and water conservation. It's not only water balance. It should be a net zero, but it should be positive than net zero. So if you see that where we have penalty of rainfalls in northern India, Indo-Gangetic plains, so the water per square feet of harvesting area into this K is called KI formula, you'll see we can store water in a building for at least use of 6 months in a multi-story building. So if it is properly designed with water tanks and purification process inside the building. So multi-stories are the best options for it, and skyscrapers are the best options for it, because you get a lot of service flows to do this type of work. Now there's a building ready infrastructure. That's the pump house, visitors, facility maintenance. It is again taken care of the enhanced commissioning stage also. Then you have building envelope system, that is ventilation, curtain walls, facades, skylights. See, this has to be done to mitigate the heat island effect. Then you have to understand the UR. I've not gone deep into technicalities here. The UV and the IR effect, how to select glass. Then glass should be only on the northern side. Most of the architects do, so we're not gone within those things. Then building environment management systems. There's the hard scale green craft which has to be brought in now. So you have to see habitat connectivity. You have to see your project component to be part of a larger project. If you have a bigger land available for a park, make it such that it can be used by neighborhood also. Then building disaster management system, that is fire, terrestrial security, earthquakes, which has to be designed for that. Now ecology comes there also. If you are building in wetlands, you are doomed in earthquakes. So there has to be a zoning plan for that also, that which are ecologically places fit for building buildings, which are not fit and which are adequately fit, where some kind of modification can be done. Then you have building waste management system, which we always take, that is solid waste, organic, inorganic, recyclables. This is the future of the world. Every building generates so much of recyclable waste in a square feet of more than 10 lakhs to development. So that is one area where the designer should think now, that how these recyclables can be channelized into generation of energy. Then building matrix system, that is for fenestration form. This is at the architecture level. This generally we do. Then here we have advanced energy metering interaction with that. Generally we do orientation. We know that glass has to be north side, but you have to go deeper for getting the energy model completely the facade. So today, if you spend some amount on that energy model facade, so tomorrow in license cost, you will be saving 50,000 on the same amount. Then BMS building management systems, you have life safety conservation. Again, optimizing energy performance is the main design objective. So this is the presentation general. Now I will be talking to you about the projects which we have done. Now, in total, I'd like to say that the buildings, whether it's at master plan level, at component level, at steel level, the design has to be water positive, it has to be air positive, it has to be energy positive and recycle positive. Thanks for this opportunity.
Thank you, Architect Bimal Kachroo, for an insightful presentation. I'm sure our audience have learned a lot. We will now be taking a short break to play our sponsor's video, and we'll be back with our next speaker.
This is my life. This is my space. Work, rest and play, and live smart my way. This is my day. Only the best for me, no other way. Forget yesterday. Dreams they do come true now that I've found you. Memories forever. Let's live smart together.
EPCO, fittings that help you live smart.